The characteristics, applications, and selection methods of the three main switching devices, Triode, MOSFET, and IGBT. All three, Triode, MOSFET, and IGBT, have 3 pins. In terms of size, the triode is the smallest, the MOSFET is medium-sized, and the IGBT is the largest. The triode is driven by current at its base. It is a component through which collector current flows. Its working principle is similar to that of a faucet, where the base acts like the switch of the faucet. It has 3 operating states: cutoff, amplification, and saturation. In the cutoff state, when the base voltage is lower than the collector voltage, there is no current flow. So, it's like the faucet is not fully turned on. There is absolutely no electrical current flowing between the collector and the emitter at all. The second distinct state is known as the amplification state, when the collector voltage is significantly higher than the base voltage, and the base voltage is also considerably higher than the emitter voltage. It is operating in the amplification state, actively amplifying the signal. The faucet is like it's opened a little bit. When the current here increases, the current over there will be amplified even more. There is an amplification factor called the beta value. When this current is multiplied by the beta value, it equals the current flowing from the collector to the emitter. The third state is the saturation state, where the collector voltage is greater than the base voltage, and the base voltage is also greater than the emitter voltage. The faucet is open to the maximum. So at this point, the collector and emitter are essentially connected, and a small current controls a large current. This makes it suitable for low power switching or small signal amplification. However, it does have a drawback. What is the drawback? Its own power consumption is high. For MOS transistors, their 3 leads are the gate, drain, and source. The difference between a bipolar junction transistor, BJT, and a MOSFET is that a BJT uses current to control current, while a MOSFET uses voltage to control current. When you apply an appropriate voltage to the gate of a MOSFET, you can control whether it is in cutoff, amplification, or saturation state. Because there is a depletion layer between the gate and the internal structure, the input impedance is high and the output is strong. It has fast switching speed, generates less heat, and offers relatively good stability. Since it uses voltage to control current, it is generally suitable for medium power and medium voltage applications, such as switching power supplies, communication power supplies, high-level power supplies, or oscillators, and so on. The IGBT combines the characteristics of both the BJT and the MOSFET. It has the collector and emitter of a BJT, as well as the gate of a MOSFET. This defines its operating state. That is, it operates in cutoff and saturation modes, which is equivalent to the function of a switch. Similarly, it is also controlled by voltage to regulate current, so its efficiency is relatively low. Its characteristic is high input impedance and high output capability. It can be used in environments that require high voltage and large current. Its operating voltage can reach above 600 volts and in some cases even exceed 1000 volts. Its range of applications includes the drive circuits in electric vehicles, high-power power supplies, welding machines, inverters, and so on. Its switching frequency is not as high as that of MOSFETs, usually below 25 kHz, whereas MOSFETs are typically above 100 kHz. Its input voltage is generally not lower than 100 volts. These 3 types of components are ones we often encounter during repairs. How can we quickly determine whether it is good or bad? Take a multimeter and measure the resistance between any 2 pins in both directions. If it conducts in both directions, that means this component is definitely bad. It has already broken down.